Hello students, today we are going to solve CET question paper in which chemical kinetics question, which was held on 10/6/2023. So let us begin with solving chemical kinetics questions. So now here we have the first question, that is 21st question from chemical kinetics. So what they are asking here, in a first order reaction, the concentration of the reactant decreases from 800 mole per decimeter cube to 50 mole per decimeter cube in 2 into 10 power 4 seconds. The rate constant of the reaction in second inverse. So this is quite simple. So what is this? So basically we know that K is equal to 2.303 divided by T, and we have log of concentration of A naught by A. So here A naught is the initial concentration of the reactant when time t is equal to 0, and A is the concentration of the reactant when time t is equal to t. Okay, now substituting all the values in this equation, what do we get? What do we get? So we get 2.303 divided by 2 into 10 power 4 seconds log of 800 divided by 50. So on simplification of this equation, we will get 2.303 divided by 2. So I am taking 10 power 4 from the denominator to the numerator. So hence it will become minus 4, and you will get here 50 ones and 50 16. So you get log 16 here. So which is once again equal to 2.303 into 10 power minus 4 divided by 2, and log 16 can be written as log 4 square. So log 4 square, how do you write here once again basically? So we will write, so where this is equal to 2.303 divided by 2 into 10 power minus 4, and it will become into 2 log 4. Now cancel out 2 as well as 2. So the final value comes out to be 2.303 into 10 power minus 4 into log 6 is 0.606020. So now the product of this will give rise to the value of 1.386 into 10 power minus 4 second inverse. So this is the correct option. So for the 21st question, option C will be correct. Okay, now take up the next problem. So what is the next problem? So it is based on the endothermic reaction, right? So we know how to draw the graph for endothermic reaction. But let us try to understand what exactly this question is. So this question is all about an endothermic reaction A to B has an activation energy. So they have given activation energy 15 kilocalories per mole, and also the energy of the reaction, which is nothing but delta H value, they are giving 5 kilocalories per mole, and they are asking you to determine the activation energy for a backward reaction, that is B to A. So B to A. Now what we need to do immediately, as soon as you get these type of questions, try to plot the graph. Okay, so now what do you take here? Basically you have to take reaction coordinate. Okay, coordinate, and on the y-axis you will take energy. And since it is endothermic reaction, we all of us know that the reactant constant, that is reactants will have lesser energy than product, assuming this to be reactant A and this is product B. Now what they have given, they have basically given the activation energy of a forward reaction, that is still this peak. Okay, so how much is this? That is 15 kilocalories per mole, and they're also giving delta H value. How do you determine delta H? The difference between the energy between the reactant as well as product, and this has been given as 5 kilocalories per mole, and they're asking you to determine the backward reaction activation energy, that is this much. So how much it is? So 15 minus 5, this is equal to 10 kilocalories per mole. 10 kilocalories per mole. So which option is correct? Option C is correct. Okay. So now let us take up the next question. So what is the next question, students? Quickly, two first order reactions have half-lives in the ratio 8:1. Calculate the ratio of time intervals T1 is to T2. The time T1 and T2 are the time period for 1/4 and 3/4 completion. Okay, fine. Now let us do first of all, let us erase this, and after that we will start with the solution of question number 23, right? Yeah. Now what they have given, so they have given 2 T halves, right? So let us assume 2 T halves to be T half 1 divided by T half 2, which is equal to, we know the T half expression for a first order reaction, which can which can be written as 0.693 by, let us assume K1 for T half 1, and similarly 0.693 by K2, 0.693 by K2. So where 693 and 0.693 and 0.693 gets cancelled, and you will get a value of K2 by K1, which is equal to the ratio of 8:1. So this is the information that they have given in the question. And finally, they are asking for the ratios of T1 and T2, okay, when 1/4 and 3/4 of the reaction is complete. So basing on that, let us write for T1. So T1 will become equal to what? 0, that is 2.303 divided by K1 log of, how much they are telling? They are telling A0 will become 1 divided by, since they are telling that for T1, 1/4 of the reaction is complete, and hence how much product will be left? So there will be 3/4 of the product left. So there will be 3/4 of the reactant left. Sorry, at time T, 3/4 of the reactant left. So which can also be rewritten as 2.303 divided by K1 log, it will become how much? 4/3. Okay, on solving this, you will be getting 2.303 by K1. You will write log 4 minus log 3. And you know how much is the log 4? So log 4 value is 0.6020 and log 3 is 0.4771. Now simplification, on simplification, you will be getting T1 is equal to, so T1 is equal to 2.303 by K1 into the value, that is the difference between 0.6020 minus 0.4771, you get a value of 0.1249. 1249. Okay. Now let us also write for T2. So what is T2? So T2 is equal to 2.303 divided by K2 log of A0 will become 1 divided by, they are saying 3/4 of the reaction is completed. So 3/4 of the reaction completed means, so how much reactant will be left? So the reactant that will be left will be 1/4, correct? So it will become 1 divided by 4. So on simplification of this, you get 2.303 by K2, okay, log 4. So you know what is log 4? Log 4 is basically, that is T2 is equal to, let us write complete, 2.303 by K2 log 4 is nothing but into 0.6020. Now since they are asking for the ratio of T1 and T2, now we will determine, or we will take this equation to be 1 and this equation to be 2. Okay, divide equation 1 by equation 2. So what it will become, students? T1 by T2 is equal to 2.303 by K1 divided by 2.303 by K2. So this expression will be multiplied. Okay, how much it is multiplied with? Into, we have simplified 0.1249 divided by 0.6020. Now basically 2.303 and 2.303 gets cancelled and this will become K2 by K1. So hence this ratio of T1 by T2 will become equal to K2 by K1 into 0.1249 divided by 0.6020. And we know the ratios already we have determined. K2 by K1 is nothing but 8 by 1. So substituting this value, that is 8 by 1 here, what do you get? What do you get? So you will be getting T1 by T2 is equal to 8 into 0.1249 divided by 0.6020, which is equal to 0.9992 divided by 0.6020. So this can be rounded off and it will become 1 is to 0.6020. Now let us see which option will be correct for this question. So which option is correct, students? So option A is correct. Okay. Now let us take up the next question, that is 24th question. So what is 24th question? So we are asking half-life period of a zero order reaction is equal to. So we all of us know the general expression, that is nth order T half formula. So what is nth order T half formula? So T half is equal to, T half is directly proportional to, what is it? 1 by A raised to the power, let me write. So T half is directly proportional to 1 by A n minus 1. So here they are saying n is equal to 0. So substituting 0 here, 0 minus 1, 0 minus 1. So it will become A minus 1. So hence T half will be directly proportional to A. So this much we have understood here. And now look at the options. 2k by A naught, they are saying that it is inversely proportional. Hence this is absolutely wrong. And option B would be correct because they are saying it is A naught by 2k. And basically T half, that is half-life period of a zero order reaction is A naught by 2k only. And this is for first order. And this is once again a dummy option. So hence option B is correct. Now coming to 25th question. So what is 25th question? So it is, the, what do you call these reactions? Complex reactions in which, two elementary steps they have given. One is the equilibrium fast step and one is the slow step. And they're asking for this, this reaction, two steps they have given. And they're asking you to determine rate law. So how do you determine? Slow step will become rate determining step. And according to the slow step, if you write the rate, so rate will become equal to what? So rate is equal to K into concentration of O. I'm writing based on the slow step, that is rate determining step. This is what you will get. But if you look at carefully, this O is missing, okay, in the main reaction. The main reaction is what? 2 moles of ozone is reacting to give 3 moles of oxygen, where there is no nascent oxygens, that is atomic oxygen. So hence, this rate law would become wrong. So what we are supposed to do? we need to determine what would be the concentration of oxygen. So that can be determined based on this fast step. So how do we do the fast equilibrium step? We will determine KEQ. So when you are determining KEQ, which is equal to, according to law of mass action, you will be writing concentration of the products, okay, into oxygen divided by ozone, that is concentration of the reactant. Now we need to determine in terms of oxygen. So we need to get this value. So hence KEQ and O3 product, and it will become divided by O2. Okay. So this is what you get. And if you bring this O2 up, so it will become concentration of, that is oxygen, is equal to KEQ O3 into concentration of O2 raised to the power -1, substituting this in the place of this oxygen. So what will you get now? What will you get now? So rate is equal to K into KEQ. So now already in the rate expression, one O3 is there, and here also you will be writing O3 and O2 -1. So this will become KEQ, and one more new constant there will be formed, and hence K dash you can write O3 square and then O2 raised to the power -1. So which option is correct, student? So option B is absolutely correct. Remaining all the options are not correct. Now coming to the next question, 26. Okay, so what is the next question? So next question, they are giving a reaction which is taking place between hydrogen and bromine to give 2 moles of HBr. 2 moles of HBr. And they are asking you to determine the molecularity as well as order by giving the rate expression. That is rate law, right? So rate law, what they have given. So it is clearly evident that there are 2 molecules taking part in the rate law, and hence this must be, molecularity must be 2. So what is molecularity? The number of molecules that is taking part in an elementary reaction, and hence in the rate also they are showing 2 reactant molecules, and hence it is clear that the molecularity of the reaction is 2. Okay. Now if you look at option A, B, C, nowhere you have molecularity to be 2, and hence all the 3 options are wrong, and only option possible is D. But we will also check it out whether order is correct or not. So how do you determine order? Okay, let me write the rate. So rate law, what they have given? Rate law, they have given it to be concentration of H2, and which is not raised to any value, means it is understood that it is raised to 1, and then Br2. So Br2 is raised to the power half, and hence order of the reaction will be equal to 1 plus 1 by 2. So which will be equal to 3 by 2. So hence option D is the only possibility that we have that is only correct. Okay. Now coming to the next question. So what is the next question, students? So according to the next question, they are asking an exothermic reaction. 1 second, students. So they are asking an exothermic chemical reaction occurs in 2 steps as follows. Okay. So exothermic reaction that is taking place in the following steps. The first step they are showing A plus B is giving rise to X, and second step they are showing X is giving rise to AB. So basically when you are having 2 different elementary steps, it is also understood that there will be formation of two transition states. So keeping that into account, we can easily rule out that option A would be wrong. Why option A would be wrong? Because there is only one transition state is formed, and hence this is wrong. Then the possibility is either B or C. But among B and C, which option is correct? Now it is determined based on fast and slow steps. And there is one relationship. What is that relationship? That is activation energy and then the rate of the reaction. Suppose if activation energy is high, then the rate of the reaction will be low, and vice versa. That is, activation energy is less, and rate will be high. So this is what is the relationship. So basing on which, let us assume that for the first reaction, they are saying it is fast. So relatively, the activation energy of the first reaction, first elementary step, will be lesser than the second step. So now let us check option B and C. In case of option B, the first transition state activation energy is higher than the second reaction transition states energy, and hence this is also wrong. Option B is wrong, and only possibility is option C. So we will also try to prove whether it is correct or not. Look at this. A plus B is giving rise to X based on the formation of one transition state. And since this step is also fast, it is assumed that activation energy for the formation of X is lesser than the activation energy which is required for the formation of AB. So this is the slow step. So hence option C is very much correct for the question. So hence option C for 27th question. Now similarly we will take up 28th question. So what is 28th question? Two reactions they are giving. A2 products and B2 products have rate constant Ka and Kb at temperature T, and activation energies they are giving Ea and Eb respectively. If Ka is greater than Kb and Ea is less than Eb, and assuming that A for both the reaction is same, then. So if you look at these conditions, it is absolutely correct. What is absolutely correct? So if you are taking two reactions according to this concept, that is, if activation energy is high, the rate of the reaction is less. If activation energy is less, rate of the reaction is more. So they are saying that the rate of the first reaction, okay, rate constant of the first reaction is greater than second reaction, means the activation energy of the first reaction should be lesser than second reaction's activation energy. This is perfectly correct, right? So if that is the case, which option is correct among the following is what is the question. Now let us read the first option. At higher temperatures, Ka will be greater than Kb. Obviously, why? Because Ka's activation energy is already less and the rate of the reaction is also high. So as you increase temperature, we all of us know that rate will increase, and we can also expect that yes, Ka can be greater than Kb. So option A is correct. Now at lower temperatures, Ka and Kb will differ more and Ka will be greater than Kb. That is also true. Why this is also true, I'm trying to say, because look at Kb. So Kb value is lesser than Ka. So it is also indirectly understood that for Kb, activation energy is very high, Eb is very high compared to Ea. So in order to make the reaction B2 products, which means that the activation energy need to be reduced. So how we can reduce basically? So by increasing the temperature where effective collisions will increase, and hence there can be more of rate of reaction. So hence, if you maintain low temperatures, since activation energy of first reaction is less, the difference between Ka and Kb will follow this order only. So Ka will be greater than Kb because Kb has already greater activation energy, and at lower temperature still more slow this reaction will become. So always Ka will become greater than Kb at lower temperatures, and hence option B is also correct. Now as temperature rises, Ka and Kb will be close to each other in magnitude. Yes, of course, this can also become possible, because after attaining a certain temperature, there is possibility that the rate of the reaction, that is rate constant of first reaction Ka and Kb, can also become close to each other in their magnitude. So that is also possible. So hence, for this 28th question, option D would be correct, all of the above. Okay. Now coming to 29th question. So which plots will give the value of activation energy? So what should be the concept here? The concept is equal to Arrhenius concept. What is Arrhenius concept? K is equal to A e to the power minus EA by RT. Now, if you apply ln, that is a natural logarithm on both the sides, you will get ln k is equal to ln A minus EA by RT. R into 1 by T I can write, right? So now this is basically is following this line regression formula where this is M and this is X and this is the intercept C, and since slope is minus, so you get a graph when you plot between ln k as well as 1 by t. So since the slope is negative, you get a graph something like this, where the point of intercept, okay, that is, this is ln A, this is what? Ln A, and what is the slope? So slope can be determined, that is, slope will become equal to minus EA by R. So hence, from which graph we can determine EA by R? So which is nothing but option, which option? Yes, option D would be correct. Okay. Whereas K versus T, it's not possible. And similarly, 1 by K versus T is also not possible. And ln K versus T is possible, but then there you won't be able to determine activation energy from the graph. And hence, only option that is correct is option D. Now coming to the last question, 30th question. So what is the 30th question? In a zero order reaction, for every 10-degree rise of temperature, the rate is doubled. So which means that they are giving the value of mu, which is nothing but temperature coefficient. If the temperature is increased from 10 degrees to 100 degrees centigrade, the rate of the reaction will become. So here we have a formula. What is that formula? So we know that rate increase will be equal to mu delta T by 10 is the formula, right? Mu they have given, that is temperature coefficient, which is equal to 2, okay? And what is delta T? Change in the temperature. So how much they are doing the change? That is 100, they are increasing from 10 divided by 10. So this will be the formula. So it will become 2 power 90 by 10. So which is equal to 2 power 9. So 2 power 9 is equal to 512 times. So hence the rate of the reaction will increases by 512 times, and option D is correct. Students, hope you have understood all these problems. And if you have any queries, you can get back to me during our class hours. Thank you, students.